Hello, my name is Visardochi and I'll be explaining examples 6.5 and 6.7 of the book today. So in the problem 6.5, we're given the price, the cost for the machine, which is $1 million. And the salvage price at the end of the 5 years of its life is $100,000. The annuity for the savings is $800,000, and the cost of operating it and maintaining it comes out to $300,000 a year. The operating hours for part A are 2,000 hours, and our interest rate is 15%. So first we want to find the annual worth for 15%. And the book uses the present worth factor to bring everything back into the present. And then the present worth is used in the capital recovery factor to give us the same value that we got. But I like to do it in a little bit different way, which we turn everything into the annual payments. The million, we use a capital recovery factor formula. And for the salvage price, we use the sinking fund factor formula to make them both into an annuity, and then we subtract from each other. So here we have the $800,000 that are yearly savings minus the $300,000 of the maintenance cost minus the $1 million that we turn into an annuity plus the $100,000 that are the salvage price turn into an annuity as well, and we get 216,516. And to turn that into a savings per machine hour, we have $108.25 dollars per hour. And then to get for part B, because that's for part A, to get for part B and turn them into the savings per machine hour for part B, we use the present worth factor to get all the yearly hours into a present equivalent, add them up, and then we use the capital recovery factor to turn them into an annuity, which I have here the present worth for the hours. And for example, I did 1,500 of the first year times 1.15 to the power of -1 plus the 2,500 of the second year times 1.15 to the power of -2 plus the third year, fourth year, and fifth year. And that gives us 6,727.76. And after we get that, the book uses the present worth factor to bring everything back into the present. And then the present worth is using the capital recovery factor to give us the same value. Then we divide the annual equivalent savings by the annual equivalent operating hours to give us the savings per hour, which was the 216,516. Divided by the hours that are turned into an annuity. And here's the formula that I used. And I apologize for reading the numbers. I have a hard time reading them in English sometimes. But yeah, that's about it for the 6.5 example. So moving on to 6.7, we are given the annual units, which are 50,000. The current costs are $270 per unit. The outsource base cost, if we decide to go with that, is $260.5. And if we go with the outsourcing, we have to get the inspection equipment cost, which the cost is $325,000. The salvage price for that comes out to $60,000 at the end of the 7 years of its life. And the operating and maintenance costs are $120,000 per year, with an interest of 18%. So first we need to calculate the annual capital cost, which we have here. And the way that I like to do it is a bit different from the book, but it is essentially the same thing. And to turn everything into annuity, I use a capital recovery factor, which you see here, for the equipment cost, and then I use a sinking fund factor for the salvage price. After we get that one, we add up the operating cost to get the AEC, which comes out to 200,325.9, because we added the 120,000 and the $80,000 together. Next, we turn this into unit costs, which is this value that we got earlier divided by the 50,000 units, and it comes out to 4.01. The total unit cost to buy comes out to the 260 that we had here, which was the base cost, plus the 4.01 that we got previously, and it comes out to $264.5 per unit. And then to compare, we can subtract the make unit cost with buying unit cost, and the make was $270 per unit, and then minus the 264.5, we get the 5.49. So that is $5.49 per unit better if we go with a buy option. And yeah, that should conclude all the examples that I have. Thank you very much.